Okay, in this video, we're going to be talking about a whole bunch of different graphs. So to start off, we're going to talk about stem and leaf plots. So in a stem and leaf plot, the data is organized by separating a number into a stem, which is going to be the leftmost digits of the number, and a leaf, which is going to be the rightmost digit. So the good thing about this is it allows you to see all of the original data. So whenever we were doing the frequency distributions and we were putting stuff into classes, we don't actually get to see the original data once we throw it into a class. Because if we throw numbers into a class and just say how many of them went in there, we don't know where in that class it actually fell. This allows us to see all of the original data, and it still gives us a pretty easy way of seeing which section has the most as well. The only bad thing about this one is it essentially limits your classes to tens, because each of the stems is going to be the leftmost digit, so which is the tens place. Okay, so this is going to make a lot more sense once we do it. So example 1, we're going to construct a stem and leaf plot for the following set of 20 scores on a history test. So first thing we're going to need is what is the minimum and what is the maximum, just so we know where to start. So in this case, just looking through, it looks like the minimum is 43 and the maximum was a 102. So that means we're going to start our stems at 4 because there's no point in doing any stems that are lower than 4 because there's nothing lower than the 40s. So what we're going to do is we're going to start at 4. Then we're going to put 5, 6, 7, 8, 9, and 10, and that's where we're going to stop. Right? We're stopping there because 102 is the last one, and if you look at the leftmost digits, that would be 10. So then we're going to go ahead and put a line. And then we're going to go through all of this data and we're going to fill it in. So starting with 4. So that would be the 40s. The only one is 43. So remember, we're not going to put 43 right here, because we already have that 4. So all we're going to need to put is 3. Essentially, if you put those together, you get 43. All right, next up, 5. So we're looking for anything in the 50s. In this case, there's nothing in the 50s there, so we're just going to leave that completely blank, which is fine. So we're going to move on to 6. So that is going to be the 60s. So I see a 60 right here. So I'm going to put a 0, that way it's 60 for 60. And then I see a 61, so I'm just going to put a comma and then a 1. So remember, this isn't 0 and 1 together. The 6 and the 1 means 61. And then if we finish looking through it, no more 60s, we're going to move on to 7. So for the 70s, I'm going to try to go least to greatest. So the least in the 70s is we see a 70. So that's going to be a 0. There are no 71s, but there are multiple 72s. So there's a 72 right here. There's a 72 right there, so I'm going to put another 2. There's yet another 72 down there. Oops, just the 2. So that's all the 72s put right there. We just list out those 2s, and we do list it multiple times since there was multiple 72s. All right, looking through for other things in the 70s. We have 75. So put a 5 right there. And then it looks like the last one for the 70s is a 76. So 6. All right, 8 is our next one, so that's the 80s. So we have an 80. So that's a 0. Next one, it looks like is an 83. So we're going to put a 3. Next up, we have a couple 84s. So there's an 84 right there. And another 84 right there. Next up, 87. And then an 88. That's it for the 80s, so now moving on to the 90s. So we have a 92, a 95, a 96, a 99. And then for 10, remember that's the 100s. So only one we got there is a 102. So this lets us really easily see that the 70s and 80s had the most grades. And if we wanted to pull back out that original list, we easily could. This would give us 43, 60 and 61, 70, 72, 72, and so on. So you can pull the entire original list back out of this, but it still lets you very easily see at a glance that 70, 80s are the most. Nobody got any 50s, and then hundreds and 40s were very rare. All right, so next one is going to be similar. It's called a dot plot. So in a dot plot, each data entry is plotted using a point above a horizontal axis. It's similar to a stem and leaf plot in that you can see all of the original data. So we're going to construct a dot plot for the data from example 1. So I went ahead and just put up that original data on the screen, that way you can see it in case you don't have the physical sheet in front of you. So again, remember the minimum that we had saw was a 43. The highest that we had saw was a 102. So we're going to start off by essentially just doing a horizontal line that we're going to be able to fit all of these numbers into. All right? So we don't necessarily have to start it at 0. In fact, since this one's 43 is the minimum, we can start it at, say, a nice number like 40. Then we're going to go through and we're going to keep going until we get all the way up to at least 102. For this example, I'm going to go by 5s, so 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, and 105 will get us just past that 102 that we need. You want to at least make sure you go higher than that, or at least to it. Okay, good news is we don't have to go searching all around the list this time. We can just go through one at a time and start plotting them. So what we do is we look at the number. In this case, it's 72. So 72 would be right about here. So right above that number, we just put a dot. That just lets us know that 72 has shown up once, at least so far. Next one would be 88. So right about here. Now keep in mind, since we're hand drawing these right now, it's not going to be perfect, but just use your best judgment about where 88 would be. All right. So next up is 96. 43. 60. 70. 84. 76. And then 72. We've already done a 72. So what we're going to do is just put a dot above it saying that that one showed up twice. 95. 61. 80. 87. 92. 102. 99. 75. 83. 72 again, so we're just going to put a third dot there. And then 84 again. So we're just going to put another dot above 84. So again, just like that stem and leaf plot, we can go through and we can pull out all of our original data from this little graph. All right. Next up is one that usually everyone's familiar with, pie charts. So a pie chart is a circle that is divided into sections that represent the categories. A section's area is proportional to the frequency of the category. So all that means is that that section's area is going to be the same as the relative frequency, as in whatever percent of the total data it is, that's also the percent of the circle it's going to be. So if it was half the data was in that category, then half of the circle will be filled with that category. So example 3, the following pie chart shows which devices students tend to watch YouTube on the most. So no specific question here, just want to make sure that everybody can read it okay. So all this is saying, we have one, where students watch YouTube. If we want to know what the most frequently used device is for watching YouTube, we would just look at the biggest area. So the section with the biggest area is this one on the right. So phone would be the most watched, or most used rather. The least used would be the smallest part. So in this case, desktop. And in this case, I even gave you the percentages, so like you can see that that was 41% and 7%. And that's reflected by the phone has a much larger area than the desktop with 7%. Okay, so now you've seen kind of what it's supposed to look like and the idea behind it of it just being a very visual way to see which pieces are bigger. We're now going to look at constructing one. So example 4, given the following table of 200 students' favorite colors, construct a pie chart. So we have the colors red, blue, green, and orange, and the number of students that picked each one. First thing we're going to need to do is find the relative frequency. So to do that, we're just going to take the number of students who picked it and divide it by the total number of students that there were. So in this case, it's going to be 30 over 200, which is going to be 0.15, or 15%. For pie charts, sometimes it's a little easier if you think about it as a percentage rather than a decimal like that. They mean the exact same thing, so use whichever one you want to think of it as. For blue, it's going to be 100, with one less zero, 100 over 200, which is 0.5, or 50%. Next one, green, so 50 over 200, which would be 0.25 or 25%. Then orange, which is 20 over 200, which is 0.1 or 10%. Okay, so for this example, we're not going to be exactly precise. We're just going to give a rough estimate so that we can kind of see which ones are bigger. All right. Now, if you wanted to, you could actually take these relative frequencies and turn them into angles to where you know the exact angle that each sliver of the pie chart should be so that it can be exact. For this example, though, we're not going to do that. We're just going to give it our best shot. All right, we're going to give a rough estimate, which will be good enough to see which one's bigger and all of that. So if I draw that little circle here, we're going to start splitting it up now. I always recommend start with any of them that are easy. So like 50%, or if you even have a number that's close to 50%, 50% is half. So we know that we can split this right in half, and that 50% is going to be blue. So all of this is blue. Again, look for any other easy numbers. Like green is 25%. 25% is just a fourth of the whole thing. Or in other words, half of the half that we have left. So if we split this in half, then one of these can be our green. Then we get down to 10% and 15%. Those aren't as easy just to eyeball, but what we can do is we definitely see that 15% is bigger than 10%. So all I'm going to do, that way we can roughly estimate it, is make it to where one of them is a little bigger. And that little bigger section is going to be red. And then lastly, that smaller section will be our orange. Again, this is not exact, but it gives a rough estimate and a good idea of what the pie chart would look like. You can use things like Excel, for example, to give an exact pie chart because the computer can do that very easily. All right, moving on to some more graphs. Our next one is called a Preto chart, and it's essentially just a vertical bar graph. where the height of the bar represents the frequency of that category. So bar graphs are something that most of you are probably familiar with. This is just a fancy name for that. So in example 4, we see one. And again, just like the pie chart, all we're going to do is we're going to look at it and we're going to try to see if we can find the highest, lowest, just see if we can read it, right? So in this one, if we want to look at each category, red looks like it's about at 30. Blue is exactly at 100. Green looks like it's about at 50. And orange is exactly at 20, which is the exact values we had in our other one. But again, this is just a very easy visual way. If we just want to know what was most people's favorite color, just look at the highest one. 100 people said blue. If you want to know what the least popular one was, go with the bottom one. 20 people said orange. Again, just a nice and visual way. I'm not going to go over bar graphs that much right here. Most of you have probably seen plenty of them in your life. So we're going to go over one more type. That's going to be scatterplot. So a scatterplot is a way to graph paired data sets, where each entry in one set corresponds to an entry in another. So basically you have two different sets of numbers and they're linked in some way. So let's take a look at an example. Construct a scatterplot of the following data gathered that shows the average temperature of that day, as well as ice cream cones sold by a small stand over 10 days. All right, so each of these rows are linked. Think of this as day 1, day 2, all the way down to day 10. Right? So on that first day, it was 80 degrees and 27 ice cream cones were sold. On day 2, it was 72 degrees and 25 were sold, and so on. Now, in order to graph these, we're going to have to turn them into what's called an ordered pair. It's really easy. All we're going to do is take the first number, put it in parentheses, and comma the second number, close our parentheses. So if anybody remembers graphing, this is just a point on a graph. All right, so we could do this for all of them. So 72, 25, 84, 36, 86, 33, 94, 40, 90, 42, 83, 30, 81, 25, 70, 18, and 75, 23. All right, keep those handy as we go to the next page, because on the next page we are going to go ahead and graph all of those. So if you need to pause the video and take a screenshot of it, that way you have it, feel free to do so now. And then we are going to go ahead and go down, and we're going to go ahead and plot all of those here. So plotting them is really easy. All we're going to do is we're going to take that first number that we put in the parentheses, that temperature, that goes along our x-axis. All right, so that tells us how far to the right we need to move. The second number, the cone sold, is going to be our y-axis. That's just going to tell us how high we need to put the dot. And wherever those two kind of intersect, that's where we put our point, and then we go on to the next one. So that first one was 80, 27. So we're going to start at 80, and it's 27, so we go up to about 27 and then put our first dot. Second one, 72, 25. So 72 would be right about here somewhere. Again, this doesn't need to be an exact thing. We just want to get an idea for how the graph looks. So 72, 25. We got a dot right about there. All right, 84, 36. Be there. 86, 33. Be there. 94, 40 would be up here. 90, 42 would be here. 83, 80. Sorry, 83, 30 would be right there. 81, 25 be here. 70, 18 would be there. And last one, 75, 23 be right about here. All right, so that's our basic scatter plot. Now, the most useful thing you can do with a scatter plot is just see if there's any trends. So like in this case, if you notice, as we look at it from left to right, it kind of seems to be going up a little bit. So if we think about that in the context of the problem, that just basically means that as the temperature is rising, the number of ice cream cones is also rising, which makes sense, right? Hotter it gets, people are probably going to want more ice cream. If it's a bit colder, they're probably not going to want as much ice cream. So this makes sense. As temperature rises, ice cream cones sold also rises. Right? Now, that's not the only thing that can happen though. So if, for example, we end up with a scatter plot that looks something like this, where everything is starting to decrease, then that would mean as this x-axis goes up, whatever variable's on the y-axis is actually decreasing. All right? So in our example, if we had found this out, it would mean as the heat goes up, the number of ice cream cones sold goes down, which doesn't make sense for our problems, but there's plenty of things that do have a downward trend. The last little possibility is you might have a scatter plot that once you plot it out looks something like this. In that case, it just means that there's really no trend to show. So if they're just all completely random, then these aren't really going anywhere. It doesn't tend to increase or decrease as one of the variables increases. So in this case, it just wouldn't have anything to say about it. And we would just say that the data shows no pattern, right? So it can either go up, go down, it could stay straight across, or it could just have no pattern at all. All right, and with that, that is the end of all of these graphs. It's just a brief overview of a few different types. Not meant to go into too much detail about any one, but just so you get to see briefly some of these types of graphs. All right, thank you for watching, and I will see you in the next notes. Bye.